Dr. Huckabee here, and this is the start of the last lecture from the spring semester that was in person. Quite the achievement that we've made the same progress this semester already, and yet we've never actually met. I hope you enjoy this lecture. It is on chapter 6 and starting the 4 fundamental types of reaction mechanisms. Here is your to-do list. So do your homework assignment, finish chapter 6, and continue to work chapter 6 problems. Don't forget our test coming up. Best of luck.
Even though we won't be back after spring break for 2 weeks, don't forget to study, please, somehow. And then also, the simple things that they tell you to do, washing your hands and whatnot, can help to, quote, flatten the curve of overall cases seen versus time. And even if, the reason why that's important is because even if the number of cases that the number of people who get infected remain the same, as long as we can spread them out over time, it will be really, really, really helpful for the system overall. So just try and be vigilant for yourself, for others around you. Even if you don't feel sick, you could be carrying it to somebody else. So just be cautious. And if you're still in your dorms when spring break is over, or you're around people, just, I don't know, try to isolate a little bit. Social distancing is key here. It's easy for us to say as professors because, you know, we're just in our offices all day. Yeah? Yeah, I'll get to all of the class administration stuff, but the answer is yes. They'll just look different than they did before. When we left, we were looking at the basic mechanisms of organic chemistry and dipolar reaction mechanisms. It's very, very important that we all get these 4 because we're going to be using them consistently throughout this course and the second semester. So first we were talking about nucleophilic attack. And we were saying that you can have a very simple reaction, such as this one. That ends up yielding you a simple product. Or you can have a much more complex reaction happen, such as this one. And if these 2 molecules happen to react, who here can, whoa, that was a bunch of lightning. Who here can look at this reaction I just drew and name what the nucleophile is? Take a second, have a look, form in your mind what you think the nucleophile is. Remember, a nucleophile is an atom. Okay, it also has a molecule it's attached to, but when we're talking about nucleophiles and electrophiles, we're going to be talking about them in this class together as atoms. So which atom is nucleophilic? Okay, I'm seeing people mouth it. Does that work? Yeah, okay. Okay. Right, so you've had a second to think about it. Which one is the nucleophile? 1, 2, 3. Nitrogen, right? Nitrogen has the lone pairs that can attack the electrophile. Where's it going to attack? Maybe it'll be easier if I show you the resonance structure of this molecule on the right. Cool. It's a really weird structure. Now, can you identify the electrophile? It's going to be carbon, right? Because the carbon has an overall partial positive we can draw a resonance structure that has a full positive. Therefore, the carbon that we're talking about will also be partially positive. That partial positive charge is going to attract one of the lone pairs from this very negatively charged nitrogen. But now I think we have a problem, right? As I have it drawn, the nitrogen is going to attack the electrophile. But if I just make that bond, what happens with this carbon here? How many bonds will it have? It's not going to have 4 anymore, right? It's going to have 5. That's exactly right. So if you ever make something during a reaction that has 5 bonds, something else has to move. It's exactly like the resonance structures we were drawing before. Therefore, we already know oxygen likes to have a negative charge. We saw it in the resonance structure here. Let's just move this bond up. If we do that, we're left with this molecule. Oop, sorry about that. There we are. So you can have a really easy nucleophilic attack, or you can have one that has some extra steps you need to think about after you make the bond due to nucleophilic attack. And so what I need you to do, yes? Oh, right. Yeah, I should have wrote the CL in there. Sorry about that. Oops. There we go. So now that you are aware of nucleophilic attack, we had this exercise from last week. Identify the nucleophile and electrophile in this video. All right. So the cat is definitely the nucleophile, and the cat's toy is the electrophile here, right? Cool. The second mechanism we have is called loss of a leaving group. What was that, 5? I think it was, yeah. Okay, so this will be 6. Great. Okay, so this mechanism is called loss of a leaving group. And we can actually use that structure that we just drew to illustrate what this is. So if we come back to that structure, whoops. Okay, this is what we were left with. We can draw the loss of a good leaving group, what we call it in organic chemistry. We'll talk a lot about it later. But essentially, whether it's with one arrow or more, you take electrons from somewhere, like in this case, the electrons from the oxygen flow back down, and because again, we would have 5 bonds to the carbon if we simply make that bond, we're going to have something else happen. Perhaps the name of this little subject line gives you the clues what's going to happen. We're going to kick off an atom from this carbon that might be happy to just be on its own. In this case, chloride is very happy to be on its own, and that would leave us with that molecule plus Cl minus. And this is actually super key here, because if you notice, our reactant had an overall negative charge, right? And on the product side, even though our reactant is now neutral, we still have a negatively charged something that keeps the charge balanced. We haven't talked about this a lot or really done it very much, but from now on, you're going to start seeing charges balanced on both sides of the equation, and it's going to be very important because they don't just go away. Matter can't be created or destroyed. That's one of the primary laws of science and physics and chemistry and everything. So we have to account for those things still being there. Additionally, you could have a much easier reaction, such as this one. Perhaps this one looks familiar from the last little drawing, but then you would have that guy if you'll notice, even though there are two charged species, the charges cancel out. A plus and a minus make a 0, so we still have good charge conservation in this reaction. Okay, so now, this is a very easy loss of a leaving group. Oh, before we go on, just notice for a second that the bottom reaction here is the exact opposite of the first one we talked about in nucleophilic attack, okay? These are two sides of the same coin because we're using equilibrium arrows, right? That means if you can go forward one way, you can go the opposite in some degree the other way. So if you can attack something, maybe the same thing can leave too. We'll see that a lot later, but we'll talk about equilibrium a lot more before we finish this chapter. Now I need you to apply your knowledge and identify for me what it is that is leaving in this video. Good, so maybe that'll help you retain. Loss of a leaving group happens when things just get out of hand for the molecule.